Okay, so welcome back to this brand new live coding session where we implement a HTTP server from scratch in C. Yesterday we left off trying to improve the file caching. Didn't really get far, and we probably have to revisit it with respect to cache invalidation. But for now, I guess I will just leave it like this. State files will just be loaded at the very beginning and will never change. So yeah, that's basically it for now. Today we want to look at a database connection, in particular SQLite. And for this, we will use basically the SQLite documentation and the agglomeration file SQLite provides. So let's go ahead, switch the scene, open a new tmux session. And open the nvim, open neovim. Oh, we have no browser right now, so open a new tab. Hello? Okay, now I just killed my browser instance. So pull it back up. Sorry. One second. Put this here. Put this here. And SQLite. And switch back. So SQLite, basically a very lightweight database. That is basically self-contained in a single file, and this is probably what we will do, what we will use for now, because it's quite simple actually. And I think there was a quick start programming SQLite in 5 minutes or less. For this, we actually used the how did they call it? Amalgamation file that basically contains all of the sources of SQLite. And I also already downloaded it, so this is this here, SQLite.h and SQLite.c. Yeah, see, it's a very big file with basically all of it in there. But the advantage of this is that we can just we don't have to link it. We can just put it in our compilation. So this is probably the first thing we do. Creating a SQLite.o, 3.o, SQLite 3.cpp, SQLite 3.h. And SQLite 3. It's only a C file. And we include that here, SQLite.o and SQLite.o. This will probably increase the compilation time for the first build, but after that, basically never again. So and I don't think we include the C flags here. We could provide some SQLite flags, but for now we don't do that. SQLite 3.0. Let's see. Okay. So that works. In here, we now probably want a database connection. I don't quite remember if you can have concurrent. Okay. So our main idea is, maybe let's draw that. We have our server. And the server manages this database. And clients can go ahead and make a post request to our newsletter. I don't know how the endpoint was called. Newsletter. And they provide some email. test@gmail.com. And then the server will validate this email address and put it into the DB. And at some point we use the DB to send out newsletters to the email addresses. That's the idea. Okay. So, I mean, first of all, we have to create the database connection. And we probably do that in our serve method. So let's introduce a method that is open database. That probably can fail. And this probably also takes a path. We will see. Okay. Okay. I wonder how... we have to read some documentation. I wonder if these calls are thread safe. Or if we have to... or if we have to protect it with a mutex, because we can do this from separate threads. SQLite thread safety. Single thread. In this mode, all mutaces are disabled and SQLite is unsafe to use in more than a single thread at once. Can be safely used by multiple threads provided that no single database connection nor any object derived from is used in 2 or more threads at the same time. Okay. Yeah, but we probably only have one connection. So we have to... we have to probably protect it by a mutex. Okay, so we can actually create connections on each thread, and we have to compile it with we have to compile it with the thread safe with thread safe 1. If no SQLite thread safe compiler is present, then serialized mode is used. This can be made explicit with 0 is threading mode, and okay, so we want this here, this compile flag. Okay. So in each thread, we probably want a separate open database. In each thread, we have a separate connection to the database. So we have, let's say, T1, T2, T3, T4, and SQLite. And they all have different cons. Or refer to the same database. And this is with the thread safe C flag. Okay. let's get back to this here and actually include SQLite 3.h. Okay, and we maybe in our makefile main.o include this here. Okay, and when we spin off a thread, in handle requests, we want to create our SQLite database connection, SQLite 3 DB, and this is an SQLite 3 star. Okay. So this is a row count. Result, what? I don't know. Okay, so we have some error message. It's just error message RC. Okay, and now we want to say open SQLite 3 open. And this takes a path. Probably we do it like this. Database path, database path, and say this is our emails.db. What? How do we call this? Users.db. I don't know. SQLite open our database path and the reference to the DB. If RC. Okay, so I wonder what that returns. Let's look at the docs. SQLite open v2. Okay, SQLite open. Is there some return? If the database is opened successfully, then SQLite OK is returned. Otherwise, an error code is returned. It's SQLite OK. So if RC is not equal to SQLite OK, then we have to basically close this whole thing. I mean, mean, is there some point where we say, okay, this we kill this thread here? No. So we at the moment we have no way of closing the connection. We can't do this. We just return null. Is there something on pthread kill? Is there some way to so we will never Or should we open the connections outside of this? I mean, this is something we could do as well. So go into our serve. Okay, where do we spin off the thread? So let's say we have our SQLite 3, our data DB cons for each thread 1. And we try to create a new con. So if SQLite 3 open database path plus plus db cons SQLite 3 star current db db cons db current db, we say pass in the current db, and does this work? Yeah, hopefully. Okay, so if this is not equal to SQLite okay, then we want to say the red val is equal to -1, and we go to the server cleanup. Okay. So we open this, and then we say current arg db is equal to current db. So this will get written into this Having a hard time with the double pointer here right now. But I think this is correct. And this, so handle request args. This just gets a SQLite 3 star DB. And here we say SQLite 3 star DB is equal to handle request args DB. And if all of our threads get killed, so we do this. When all of our threads get killed, we also do this here, SQLite 3 free, or no, it's close. SQLite 3 close. And then the db cons add I. Okay. Okay. So in our post request, handle post request, we probably want to put in DDB. So handle post request, we get, let's make it a little bigger, we get an SQLite 3 DB. Let's make, okay. So here, we have the newsletter sign up. We probably want some email validation. And I also don't know, so in the end, one second. One second. Okay, so it doesn't matter. Want to validate an email. We don't know what to do. Who is validate the email input. And down here, we probably want to put the email into the database. So for this, we use SQLite statements. Okay. Okay, we want a prepare. Want to prepare, and then we want to exec a wrapper function that does and finalize for a string for one or more SQLite statements. Okay. So to To execute an SQLite statement, it must be compiled into bytecode program using one of these routines. Or in other words, these routines are constructors for the prepared statement object. The legacy and should be avoided has an extra prep flag. Okay. So database connection. So we want some SQLite 3 prepare v2. And this gets the DB connection. SQL statement, which we have to define. Where was it? I think they were using fprintf in this case. Programming interface. So here they were using exec. Okay. Maximum length of ZSQL in bytes. Okay. So the idea is probably to prepare, and what does finalize do? SQLite prepare. SQL injection. I think you were using question marks here. Let's see, SQL language, Pragma, strict. Where is the question mark? Okay, let's read that. So when n bytes is positive, is read up to the first 0 terminator or until the n bytes have been read, whichever comes first. If n byte is 0, then no prepared statement is generated. If the caller knows that the supplied string is null terminated, then there is a small performance advantage to passing an n byte parameter, that is the number of bytes in the input string including the null terminator. Note that n byte measure the length of the input in bytes, not characters, even for the UTF-16 interfaces. pztail. Okay. Okay, so bind, also something we probably want to use. Okay. Okay, so prepare the DB, then the statement, which we can define as insert statement. This is insert into users, and then email values. Is that correct? Insert into values. My goodness. What are these pictures? Come on. So insert into users, email values, and then a question mark, I guess. So we also need a statement. So SQLite 3 prepare. So we have some SQLite 3 statement. Pointer statement, and we parse a pointer to the statement as first the query, so insert statement, the size of the insert statement, and the statement. Pointer to unused, so we probably don't need this. Null. And this also returns an error. If it returns an error, we probably have to free the error. Yeah, here. Okay. So RC is equal to this. Where does it know? So prepare can. So if RC is not equal to SQLite, okay, we have a problem, and probably we just do a init empty response and internal server error and return. Okay. Okay, so we need some bind method. Where is this? Programming interfaces, no. Application defined SQL functions here. List of functions, SQLite 3 bind. Okay, so there are different binds. We want a bind text. Bind null. Probably bind text. Okay, so bind text. Where is this explained? Bind text. So the first argument is always a pointer to the statement. The second argument is the index of the SQL parameter to be set as an index of 1. So here we say SQLite 3 bind text, and then the statement, which is our statement. Okay. Then 1. And the third is a null pointer, is the value to bind to the parameter. So this would be somehow our email. And so what is 64? Okay. Email. Is that it? And void. So a function pointer. So if a non-negative fourth parameter is provided to SQLite bind text, must be the byte offset where the null terminator would occur, assuming the string were null terminated. If any null characters occurs at bytes offset less than, resulting string value will contain embedded nulls. Void star. Oh no, so this is an int. The length of this, so yeah, this is now the question. So this is kind of the email length. I don't know. Must be the byte offset where the null terminator would occur. So has this. Does it have to be a null terminated string? Where has the number of bytes? The value is the number of bytes in the parameter. Okay. So yeah, maybe this is just the length. Then the fifth. To the blob and string binding interfaces controls or indicates the lifetime of the object referenced by the third parameter. These three options exist. A destructor to dispose of the blob or string after SQLite has finished with it may be passed. It is called to dispose of the blob or string even if the call out to the API fails. Static may be passed to indicate that the application remains responsible for disposing the object. In this case, the object and the provided pointer to it must remain valid until either the prepared statement is finalized or the same SQLite is bound to something else. Object is to be copied prior object. So what is may pass to indicate that the application remains responsible for disposing the object. Yeah, so this is probably what we want, SQLite static. Okay. So, and also this is again RC. If RC is not equal to SQLite, okay. Do the same thing here. And then we probably have to prepare. So bind, run by step, reset the prepared statement using also we could keep this statement. Step 2. Okay, so we could keep this statement around. The entire time so that we don't have to prepare it every time. Okay, so that's nice. So we bind text to the statement, and then we want to step probably on the statement. Okay. Let's keep it like we did it before. Okay, and now we want to say RC and SQLite reset, destroy the object. Is called to reset a prepared statement object back to its initial state, ready to be re-executed. Any SQL retain their values, so we want to clear the bindings. So SQLite, we want to reset the statement, and we want to clear the bindings. So reset, clear the bindings. also this. I mean, if we are in a faulty state here, this could be bad. If RC is not equal to SQLite, okay. Do the same thing here. And the same thing here. Okay. We could also say assert RC is equal to SQLite, okay. Yeah, okay. Okay. Okay, so step. Yeah, I worry that if this gets broken on the way, then how do we handle this? So to do how do we handle broken statements? Okay. Okay, so in this handle requests, we also need some statements. So we may indicate that with returning a negative number here in handle post requests. So we may handle this with returning the RC. And then we have to flush it out. I mean, for now, just leave it like this. So we clear the bindings in our handle requests. We now want to create a statement. So SQLite 3 statement, and we want to say SQLite 3 prepare. I think so this was something we had before, but I think I deleted it. Yeah, I deleted it. That was kind of stupid. Okay. So prepare v2, and this gets the DB, the insert statement, the size of the insert statement, it gets the statement and a null pointer. Okay. So RC is equal to this. Or we may pass a pointer to RC. That's something we could do. Yeah. So prepare this if RC is not equal to SQLite OK, then we want to just return null. Okay. 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 Clear bindings and so step. What is finalize? By calling step. One or more times. How do we get the result? How do we get the result again? Where was it? Where were all the functions? Prepare, column bytes, column blob, column count. Okay. So this should in theory be it. So now we only need to get somehow the email address. So HTTP forms requests. How does the request look like when no. What does it send when what does it send? So forms no, HTML forms requests. Sending form data. So how does it convert it? Host. Okay, it says say is equal to hi and 2 is equal to mom. So we will have something like email is equal to something. Okay. So yeah, we somehow would have to we'd have to validate the message body now. So if the message body dot length is less than let's make this email prefix email equal maybe also U8 min email length, and that is a minimum email length. So it's 3 characters. Name at domain. Okay, so it's 3. So if the message body length is less than the size of the email prefix -1 plus the min email length, then we just return a bad request. Okay. So now, with that out of the way, we want to mem equal email prefix a message body dot pointer email prefix size of the email prefix -1. Okay, so if not mem equal, then we just return this. So our email pointer is equal to message body plus dot pointer plus the email prefix size of the email prefix -1. Okay. And now we would have to validate this. So, or we could also say string email is equal to the message body dot pointer plus the size of the email prefix -1 and the message body dot length minus size of the email prefix -1. So this is the email, and now we want some validation. Validate email. We put in the email. If not validate email, also make this a bad request. And now we have to say this. So this is the email.pointer and this is the email.length. I mean, we could and now we only have to implement a validate email, which takes a string email, and we try to find the character inside the email, email.length, and we try to find an at. This, I think, returns a pointer. Yes. So this is the pointer, car star at pointer. If not at pointer, just return 0. If the if the at pointer so we now have the name length, u32 name length, which is equal to the at pointer minus the email pointer, and we have the domain length, which is equal to the email.length minus the name length minus 1. If domain length less than or equal to 0, I mean, this cannot happen. So if the name length is equal to 0 or the domain length is equal to 0, then we return 0. Otherwise we have a valid email. I return this versus return C. Okay. And yeah, maybe this is how we do it. And we also have to check whether it's only ASCII and no space, I guess. Email validation. Let's check if algorithm Wikipedia. Maybe there's something. I think it has to be ASCII. Is an email required to be ASCII? Okay. So I think this in and of itself could potentially have does prepare with bind prevent SQL injections. We don't alter our and remains intact. Okay, we can try if we can inject something. But for now, I think this is just that. And yeah, let's see if it compiles. I don't think it compiles, but okay. So name length. Return this not equal and okay. Narrowing conversion. Search body. From long unsigned int. Okay, I think that's a problem. Handle post request. So here we create, at least we should create our statement, and in our post we want to probably put this statement. Okay, 238, make this a car store. I was thinking about in mem, we could say something like pound define const mem equal, and this is the literal, and closing define pound define with this. C preprocessor multi-line. With parentheses like this. Okay, I don't know. Function name. Fn name. So it'd be like car star. And it takes in a, I don't know, car star a mem size length haystack, and then we go through we go through all of them. So if mem equal in this kind of length, so the caller probably has to ensure that this fits. So if how do we do this? So for and I is equal to 0, I is less than length, plus I. I mean, this thing already has a size. So it's more like size of the literal. And then if so we have car star A, car star B, plus A, plus B, A is equal to haystack. Oh, we could plus haystack, car B is equal to literal. How do we do it here? Maybe we'll, no. If star haystack is not equal to star B, return false. So mem equal. No, this was mem equal, so this is a bool. Return true. And this, and this, and this, and this, and this, and this. I wonder if this works. then we could say something like, where we defined our email prefix, const mem equal email prefix, and the email prefix. This should put the code here. And then we should have something like where is it? Mem equal email prefix, and we only have to provide this pointer here. I wonder if that works. Oops. Okay, so -1. Oh, so we should provide a length? No, we don't have to provide a length. The caller has to ensure that the length of the haystack is at least the length of the literal. Okay, so bool fn name. Maybe we delete this here. Oh, nope. Literal was not declared in the scope. In definition macro. So we probably can't do this here because we just said it's the email prefix. So when we say this here, does that work? Control flow reaches okay. In main miss something? Function definition is not allowed here before. Okay. Maybe we put it in mem. Let's just see what happens. An expansion of macro. Expected closing parentheses at the end of input. Multiprocessor, multi-line macros. C preprocessor docs. Yeah, so it does this as well. Const mem equal. Here we set this, and here we wanted to define the function. Mem equal bool fn name. If we just do this here, doesn't work. Is there something we are missing? I is less than the size of the literal, -1. B is equal to the literal. I don't see where this is going. Okay, so I think we leave it like this for now. We will come back to this tomorrow. Okay.